We shall now look at some cantilever beam problems for practice to find the axial force, if any, shear force and bending moment values set up at an imaginary section along the beam length. The first practice problem is shown in the diagram. The cantilever beam consists of 4-point loads with a uniformly distributed load. You may pause the video at this point of time, solve for the unknown resistive forces and moments at various sections along the beam length, draw the corresponding diagrams and find the maximum of these values. You may then continue watching the video to find the answer key to this problem. The answer key to the practice problem 1 is shown here along with the necessary calculations. We find that there is no axial force generated since no horizontal load acts on the beam. The maximum shear force is found to be 18 kilonewtons acting over a part of the beam's length, including the fixed end. The maximum bending moment is found to be 77 kilonewton meter, also acting at the fixed end of the beam. These maximum values shall be useful to find the maximum induced shear stress and bending stress respectively in later chapters and design the cross-section dimensions accordingly or modify the beam material or both as a part of machine design. The second practice problem consists of a combination of a uniformly distributed load and a uniformly varying load on top of it, along with a concentrated moment as shown here. You may pause the video now and continue watching the video after solving for the unknown resistive forces and moments. In this example as well, there is no horizontal load acting on the beam. Hence, there is no axial force developed within the beam. The maximum shear force is found to be 80 kilonewtons located at the fixed end. The maximum bending moment is found to be 36.67 kilonewton meter, also acting at the fixed end of the beam. Further, it can be seen that the bending moment changes its value from negative to positive values at a certain location where the bending moment value is found to be 0. Hence, this is a point of zero bending and is called the point of contraflexure or the point of inflection. To find its approximate location along the beam length, we simply equate the bending moment at x to 0. Hence, the point of contraflexure or inflection is found to be at 1.43 meters from the free end. Now, the final and the third practice problem based on the cantilever beam for shear force and bending moment is as shown in the figure. An extension frame is provided at the free end over which an inclined point load acts along with the other loads on the beam. This may be simplified in terms of two component point loads along with the net moment developed acting at the free end of the beam. You may again pause the video to solve the problem and then continue watching the answer key. Here, a constant axial resistive force of tensile nature acts throughout the beam length at all sections with a value of 10 kilonewtons. The maximum shear force is found to be 102.32 kilonewtons and acts over a part including the fixed end of the cantilever beam. The bending moment has a maximum value of 334.93 kilonewton meter, which is also seen to act at the fixed end. In the next lecture, we shall consider a central point load acting over a simply supported beam for the shear force and bending moment calculations.